Okay, so structural isomers are the next thing we probably need to talk about. And structural isomers are compounds that have the same chemical formula but different structural formula. So, what that means is that when we draw them or when we're identifying them, we're basically going to take a look at the formula and do the best we can to come up with 2 different or 3 different or 4 different or 18 different versions of it. So, an example that's given to you on your worksheet is there are 2 structural isomers for the formula C4H10. One is butane, which is easy to draw, which would look something like this. The ANE tells me all the carbons are single bonded together. The but tells me that it's a 4 carbon chain. So when I draw this structure, I'm going to draw 1, 2, 3, 4 carbons. I'm going to bond them together singly. I'm going to number them 1, 2, 3, 4. And then I'm going to go back and identify and make sure that each carbon has 4 bonds. So 1, 2, 3, 4. So that's butane. The other structure that we could potentially come up with, and note that it's 2-methylpropane, so it's all single bonds. Prop means 3 carbons, and 2-methyl tells me it's a branch, and it's a 1 carbon long branch, and there's 2 of them. So 2-methylpropane would look something like this. And the interesting thing about this is that one of them is lighter fluid, essentially. So this is the things that you would find in a lighter that you light your candles with. And this one here, over here, is something that we use to cool refrigerators with. So they have the same chemical formula, C4H10, but they have a different structural formula. That's what we call them, structural isomers. So in talking about the structural isomers, one of the things that's important to consider is that when you want to draw the most basic structure, which is a linear structure, so in this case, linear would be a butane, and then you want to take one of the carbons off and add it as a branch, and every time you add it as a branch, you want to make sure it's not making the chain longer. So butane and 2-methylpropane are 2 different structures. I'm going to ask you to draw the isomers of C5H12. I'm telling you ahead of time that there's 5 of them. So the first thing I'm going to do is I'm going to draw the easiest structure, which is 1, 2, 3, 4, 5 carbons long. Each of those carbons is a single bond. And then to each of those carbons, I'm going to bond hydrogens to make sure that each carbon has 4 bonds. And when I do that, I get a structure that when I label it and I count it will equal, let's see, 1, 2, 3, 4, 5, all single bonds. So it's going to be ANE, and because it's 5 carbons long, it's going to be pentane. And that's it. So that's one of the structural isomers that we can draw for C5H12. Another one is I'm going to take one of the carbons off and I'm going to place it somewhere on the chain. So I'm going to start with 1, 2, 3, 4. I'm going to single bond them together and I'm going to count them 1, 2, 3, 4. Now, if I create a methyl branch here, that gives me a 5th carbon, and that makes the chain 5 carbons long. So I don't want to put it there. So if I put the carbon here, that will give me a methyl branch on the 2nd carbon, which is different than a 5 carbon long chain. So I'm going to go back and I'm going to add my hydrogens here. And so now I have a structure that is different than pentane. But when I label it, or when I actually name it, it's all single bonds. So it's an ANE, and it's 4 carbons long. So it's a bute. So it's a butane, and there's a methyl group that is 1 carbon long. So it's a methyl. And as a result of that, it's on the second carbon, so it's a 2-methylbutane. Well, there's one more structure that we could potentially draw, and when I draw that last structure, I'm going to take one of the carbons off, and I'm going to add it as a branch somewhere. So it's going to look something like this. 2 and 3, all single bonded, so again, it's an ANE. So that's all single bonds. And I have my methyl branch here and a methyl branch here. And it's the chain itself is 3 carbons long, so it's prop. So it's a propane. And I'm telling the world that it has 2 methyl branches. And then it's a methyl, but I should probably number this chain 1, 2, 3, and on the second carbon there are 2 methyl branches, so I'm going to call it a dimethyl and a 2,2 dimethylpropane. So I need to go ahead and add my hydrogens to make sure that everybody's got four bonds. So that would look something like this. And as a result of that, I now have 3 different structural isomers of C5H12. I have pentane, I have 2-methylbutane, and 2,2-dimethylpropane. And when you go ahead and do the 18 isomers of octane, what I would start with is I would draw octane, which is 8 carbons long, and then I would draw a 7 carbon long chain, placing a branch everywhere that I can to make sure that it's a different structure, then make a 6 carbon long and a 5 carbon long and a 4 carbon long and go from there. And so hopefully this helps. If you have any questions, just shoot me an email, and good luck.